Hey everyone, welcome back to another video, right? This is for the 2025 Math Methods exam one that just happened today, so I hope this exam went well for you all. I've just managed to get a copy and just go through it. Now the questions don't look theoretically too difficult, but it looks really time consuming, a lot of heavy algebra, and yeah, it just kind of wears you down at the end. So I just wanted to make my suggested solutions for this. So let's get straight into it. Y is equal to x squared cos of x. Let's find dy dx, right? We're simply using product rule. That's going to be the first function times the derivative of the second function plus the second function times the derivative of the first. And now we can just write it like this, right? So that's the first question. So let f of x be equal to 6 times square root of x plus 1 and then plus 5. Find the gradient of the tangent to y is equal to f of x at x is equal to 8. So when we do derivatives, it's usually helpful to take away a square root and write it instead as a power to the half, right? And now we want to take the derivative. So when you take the derivative, you do chain rule, you're just going to get this. And the plus 5 would disappear because the derivative of a constant is just 0. Right, and then you get... Now, to the power of negative half just means you can put it, right? You can flip it upside down and then put a square root on it. And then we can find, we can find the value of the derivative at x is equal to 8. So that's 3 over square root of 9. That's 3 over 3. That's 1. Right? So f dash of 8 is equal to 1. Let g of x be a function defined for x greater than 3 over 2, so that g dash of x is equal to 1 over 2x plus 3. And g of 1 is equal to 0. Let's find g of x. So how do we go from the derivative to the original function? Well, of course, you have to do an antiderivative. Now, a lot of you might be a bit confused or weirded out by this type of antiderivative, right? You don't see it too often. But whenever you have an antiderivative like this, all you need to do is 1 over this number right here in front of the x, and then log base e of this entire thing right here. And it's a general antiderivative, so don't forget the plus c here. Right? So we know our function g of x is going to be equal to this. But we still need to find the y-intercept here, the c value, right? So we can use this information that g of 1 is equal to 0. So let's find g of 1. That's a half log base e. 2 plus 3 is 5, and then plus c. And then g of 1 is equal to 0. So of course c is equal to negative a half log base e of 5. Now the question actually says to find g of x, right? So we're actually going to write that. That's going to be half log base e of 2x plus 3 minus a half log base e of 5. That's going to be the value, well, not the value, the rule of g of x. Okay, let f with a domain of 0 to 2 pi, right, with a rule of 2 cos of 2x plus 1, right, so that's f of x. State the range of f of x. Now I want you guys to think back, right? This number right here represents the middle line for the function. And then the amplitude tells us how much above or below the midline it goes. So the function goes 2 above the midline and 2 below the midline. So ran f, which stands for range of f, well, what's the lowest value that it's going to reach, right? The middle line is at 1, and it goes 2 below that. So -1 is going to be the lowest value it reaches, and 3 is going to be the greatest value that it reaches. Solve f of x is equal to 0 for x. Okay. So 2 cos of 2x plus 1 is equal to 0. If you rearrange this, you'll get cos of 2x is equal to -1/2. Do not forget that the domain is from 0 to 2 pi, right? So x has to be between 0 to 2 pi. Now what can we do? Now we can do let a equal 2x. Right now, if x was between 0 to 2 pi, a is equal to 2 times x. So a is going to be between 0 to 4 pi. Right? And we get cos of a is equal to -1/2. A is between 0 and 4 pi. Now let's try to solve this. So think about what kind of angle makes cos become a half. Well, that's going to be an angle of pi on 3. And then we want cos to be negative, so it's going to be over here. Right, so let's see what we get. We have 1 pi on 3, 2 pi on 3, that's one of our solutions for a. 3 pi on 3, 4 pi on 3 is a solution. 5 pi on 3, 6 pi on 3, 7 pi on 3, 8 pi on 3. That's a solution. 9 pi on 3, 10 pi on 3. Now remember that a is the same as 2x, right? And we want to solve for x, so let's just replace a with a 2x. And now we can simply just divide each value by 2, because we want x by itself, not 2x. So we get pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Right? Okay. So that's going to be our values of x. Sketch the graph of y is equal to f of x for x is an element of pi on 2 to 3 pi on 2. Okay. So only from pi on 2 to 3 pi on 2. Right? Now remember, the cos graph will look something like that, right? Just rough shape. So first, let's find f of pi on 2, right? So we can get the endpoint. So f of pi on 2 is going to be 2 cos of pi plus 1. That's -2 plus 1, that's -1. So endpoint over here. Let's find f of 3 pi on 2. That's going to be 2 cos of 3 pi plus 1. Now cos of 3 pi is also -1, so -2 plus 1 is also -1. And now let's try to see where the x-intercepts are. There's an x-intercept at pi on 3, but that would be somewhere over here. That's outside of our domain that they've given. The next one is 2 pi on 3, which is within the given domain. So let's put that over here. And then the next one is 4 pi on 3, which is also within the given domain. So that's going to be around here. Right? So, yeah, that makes sense. Yeah, that should make sense. And now we can put this in. Right, so let's label 3 pi on 2, comma, -1, pi on 2, comma, -1. We got 2 pi on 3, comma, 0. and then 4 pi on 3 comma 0, right? And we actually also have pi comma 1, right? And the reasoning for this, how did we find this out? Well, remember, the middle of the line, or the middle line for our equation is y is equal to 1, right? So the graph would start here at a maximum, and then a quarter of the period later, and a quarter of the period is pi on 4. So a quarter of the period later, it would be at the middle line. And then another quarter of the period later, so that would be at pi on 2, it would be at its minimum. And then another quarter of the period later, it would be at the middle line at 3 pi on 4. And then another quarter of the period later, it would be at its maximum, which is at pi. So that's how we found it out. Use the quarter period. It really does help, right? So yeah, that's going to be it for that one. Let's just get rid of this line here. Okay, the probability distribution for the discrete random variable x is given in the table below, where k is a positive real number. Show that k is equal to 10 or k is equal to 15. Well, what do we know about probability distribution tables? The probabilities have to add up to 1. Now, what's 4 over k plus 2 over k? That's 6 over k. And what's 2k over 75 plus k over 75? That's 3k over 75, right? Now, you can actually simplify 3k over 75 to k over 25, right? And then what we can do is we can just add these fractions together. So let's make it a common denominator. Right? And what do these, what does the sum of these probabilities have to equal? Has to equal 1. So, okay, let's just try to solve this. We get 150 plus k squared is equal to 25k. So we get k squared minus 25k plus 150 is equal to 0. So we need two numbers that adds up to negative 25 and two numbers that multiply to 150. Right? That's going to be negative 5. Oh, sorry. That's going to be negative 10 and negative 15. Right? Because negative 10 times negative 15 is 150, and negative 10 plus negative 15 is negative 25. So k squared minus 15k minus 10k plus 150 has to equal 0. Factor out a k, and then factor out a negative 10. Now we get k minus 10 times k minus 15 is equal to 0. Null factor law. Therefore, k has to equal 10 or k has to equal 15. Right, so there we go. Let k equal 15. What's the probability that x is greater than 1? So x being greater than 1, that means we can either have x is equal to 2 or x is equal to 3. So the probability that x is greater than 1 is the same as the probability of x being equal to 2 plus probability x being equal to 3. Right? Now, what's the probability that x is equal to 2? That's k over 75. And probability x is equal to 3 is 2 over k. Now, remember, k is 15. So we get 15 over 75 plus 2 over 15. Now, 15 over 75, you can simplify that to 1 over 5. Right? Yes, you can simplify that to 1 over 5. Right, let me just double check that for a second. Yep, so... And then we can add these fractions together. Let's make it a common denominator. So 3 over 15 plus 2 over 15 is 5 over 15. That's actually going to be 1 over 3. So therefore, the probability x is greater than 1 is going to be 1 over 3. Right, so I hope that makes sense. Find the expected value of x. Right, so just remember, how do we find expected value? You take the x value, multiply by its corresponding probability, and then add that with the next one multiplying, and then add that with the next one multiplying, etc., etc. So 0 times 4 over k is just 0. And then add that with 1 multiplied by 2k over 75. And then add that with 2 times k over 75, which is also 2k over 75. And then add that with 3 times 2 over k, which is 6 over k. Okay, so remember k is 15, right? K is 15, so we get 30 over 75 plus 30 over 75 plus 6 over 15. Now 30 over 75 is actually just 2 over 5. And 6 over 15 is actually just 2 over 5 as well. So we get 2 over 5 plus 2 over 5 plus 2 over 5 is actually 6 over 5. So the expected value of x is 6 over 5. Right? Okay, question 5. Solve e to the power of 2x minus 8 times e to the x plus 7 is equal to 0 for x. Okay, well, let's see. E to the 2x, we can write that as e to the power of x squared, and the rest we can leave the same. And now you'll see that we have e to the power of x coming up multiple different times, right? So we can say let a equal e to the x. Let's rewrite the equation. We get a squared minus 8a plus 7 is equal to 0. Now we need two numbers that add up to negative 8 and two numbers that multiply to 7. Okay, so let's see what this can be. I'm thinking negative 7 and negative 1. Right, so a squared minus 7a minus a plus 7 is equal to 0. Factor out an a from the first one, factor out a negative 1 from the second one, sorry. And then we get a minus 1, a minus 7. So a is equal to 1, or a is equal to 7. But the question doesn't ask us to solve for a, right? It asks us to solve for x. What was a equal to again? A was equal to e to the x. Right? So what can we do now? Well, we know the solution to this is just going to be x is equal to 0, because e to the power of 0 is 1. And the solution to this is going to be log base e of 7. Because e to the power of log base e of 7 is just 7. Right? Because e and log base e would cancel out. So we get, therefore, x is equal to 0, or x is equal to log base e of 7. Okay, let g of x be the same function defined before, where x is an element of the real numbers. The function g of x has exactly one stationary point, right? Which is a local minimum. So it might look something like this, right? Just for example. Find the largest value of a such that when g is restricted to the domain of negative infinity to a, it has an inverse function. So remember, what's the condition that you need to have an inverse function? You need to be 1 to 1, right? So what could we restrict the graph to so that it becomes 1 to 1, right? Well, if you think about it, if I get the graph all the way from here to here, and I cut it off right at the local minimum, then it's going to be 1 to 1. It's going to have an inverse function, right? So the domain, right? The domain, it should go from negative infinity to the x value of the turning point, right? Because that's right here. That should be our domain. That cuts off the graph exactly to where it has an inverse function. So that means that the value of a that they have is really just the x value of the turning point. So let's find that. Let's do g dash of x. That's going to be 2e to the 2x minus 8e to the x. And then the 7 disappears, of course, because derivative of a constant is 0. Now we can apply the same trick, right? So we're going to say let g dash of x equals 0, because we want to find the local minimum, right? The stationary point. So we get 2e to the 2x minus 8e to the x is equal to 0. This is the same as this. And we can say let a, we shouldn't say let a actually, because a has already been used in the question, so it wouldn't be too nice. Let's say let c equal e to the x. So we get 2c squared minus 8c is equal to 0. We can factor out a 2c, so we get c minus 4 equal to 0. Using null factor law, we get c is equal to 0 or c is equal to 4. Now, what was c again? That was e to the x. Now, e to the x is equal to 0 has no solutions, right? We're going to reject this because e to the x is actually always greater than 0. It can't give a value of exactly 0. This, however, will be log base e of 4, because e to the power of log base e of 4 is equal to 4. Once again, because e and log base e would cancel out. So that's going to be our final answer. Oh, well, not a final answer, right? So this is the x value of the turning point. We know that a has to have the same value as the x value of the turning point, so a is log base e of 4, right? Make sure to answer the question, because we need to find the value of a, not x or anything else. Okay, consider the binomial random variable with 6 trials, so n value is 6, and the probability of success is a quarter. Find the variance of x. So if you remember the formula for variance for a binomial random variable, that's np times 1 minus p. Right, so what's n? It's 6, p is a quarter, 1 minus a quarter is 3/4. So let's go to the top. So the top row is 6 times 1 times 3, that's 18. And then the bottom row is 4 times 4, which is 16. Now we can simplify that to 9 over 8. Right? So therefore, variance of x is 9 over 8. Okay, determine the probability that x is greater than or equal to 5. Give your answer in the form a over 2 to the power of b, where a and b are both integers. So probability x is greater than or equal to 5. Well, what values can x actually take? Right? X could either be 0. So there's only 6 trials, right? So 0, 1, 2, 3, 4, 5, 6. So if x has to be greater than or equal to 5, that means x can equal exactly 5, or x can equal exactly 6. So that's what we're trying to find. Let's use the binomial distribution formula. There's 6 trials. We want 5 of them to be successful. Probability of success is a quarter to the power of 5 times 1 minus the probability of success, 3/4 to the power of 6 minus 5. let's apply that here as well. What's going to be 6 choose 5, right? That's going to be 6 factorial over 5 factorial times 6 minus 5 factorial. That's actually just going to be 6. Right, so we get 6 times 1 over 4 to the 5 times, so 6 minus 5 is just 1, so just times 3 over 4. Now, 6 choose 6 is just going to be 1, right? So we just get 1 over 4 to the 6. And obviously 6 minus 6 is 0. Anything to the power of 0 is just 1. So we get 1 times this times 1 is just going to give us this. So let's look at this. 6 times 1 times 3, that's 18, over 4 to the 5 times 4, that's 4 to the 6, plus 1 over 4 to the 6, that's going to be 19 over 4 to the 6. Now the reason I didn't actually calculate these values, like actually calculate the powers, is because they want it in a form that has powers, right? So there's no use calculating the actual numbers. So probability x greater than or equal to 5 is going to be 19 over 4 to the 6. Okay, on to the next question. So it's a fairly long exam, right? So f of x is equal to x cubed minus x squared minus 16x minus 20. Verify that x is equal to 5 is a solution of f of x is equal to 0. Okay, so let's substitute 5 and see what we get. 5 cubed is 125. 5 squared is 25. 16 times 5 is going to be 80, and then minus 20. So what's 125 minus 25? That's 100. What's minus 80 minus 20? That's minus 100. So we get 0, right? Therefore, x is equal to 5 is a solution of f of x is equal to 0. Right? So all we have to do is just sub it in. That's it. Okay, express f of x in the form x plus d squared times x minus 5, where d is a real number. So they're just asking us to factorize f of x. They gave us a big hint, right? They said that x is equal to 5 is a solution of this. So that means we can actually take our function and divide it by x minus 5, right? If you guys remember, factor theorem, remainder theorem. And then we can just do polynomial long division. So we'll put x squared here. X times x squared is x cubed. Negative 5 times x squared is negative 5x squared. Let's do minus. So 5x squared minus x squared is 4x squared. Let's bring down the negative 16x. We're going to do plus 4x. X times 4x is 4x squared. Minus 5 times 4x is negative 20. So now, it's negative 20x, right? And then, so we get 20x minus 16x, which is actually 4x. And let's bring down the negative 20. So now we're going to do plus 4. X times 4 is 4x. Negative 5 times 4 is negative 20. If we minus, now we just get 0. There's nothing. There's no remainder left. Right? So f of x is actually going to be this multiplied by this plus the remainder. But there is no remainder. Right? So x squared plus 4x plus 4 times x minus 5. X squared plus 4x plus 4 should look very, very familiar because that's actually x plus 2 squared, right? And so that's going to be our final answer. We've just expressed it in the form that they want. All right? Okay, consider the graph of y is equal to f of x as shown below. Complete the coordinate pairs for all axial intercepts of y is equal to f of x. Okay, well, we know from this equation that there's actually one intercept at x is equal to 5. There's one intercept at x is equal to -2. And if you want the y-intercept, well, the easiest thing you can do is just go back up to here. If you substitute in 0 for x, -20 is the only thing that'll be left. Right? Okay. Okay, let g of x equal x plus 2, and the domain is all real numbers. State the coordinates of the stationary point of inflection for the graph of y is equal to f of x times g of x. Okay, let's actually find the equation for this. So remember, f of x, we can write it like this. X plus 2 squared times x minus 5. G of x can be written as just x plus 2. Now, what's x plus 2 squared times x plus 2? That's x plus 2 cubed. And then we're multiplying by x minus 5. Now, if you remember, if we have an x plus 2 cubed like this in our equation, and it's multiplying with something else, at -2, x is equal to -2, the graph is going to look something like this. Right? So that's going to be our stationary point of inflection. So therefore, the coordinates are actually going to be -2, 0. Write down the values of x for which f of x times g of x is greater than or equal to 0. Okay, if we want f of x times g of x to be greater than or equal to 0, we can have one of two important cases. Right? Oh, what the hell? So we can have one of two important cases. We could have f of x is greater than or equal to 0, and at the same time, g of x is greater than or equal to 0. Or, the other case could be f of x is less than or equal to 0, and at the same time, g of x is also less than or equal to 0. Now, this should make sense because a positive number times a positive number would also be positive. A negative number times a negative number would also be positive. Right? So these are the two cases that we can have. And then, of course, they can also be equal to 0. Right? Because it's greater than or equal to 0. So when is f of x greater than or equal to 0? Well, it's equal to 0 at -2, and it's greater than or equal to 0 also at from 5 to infinity. Right? Because over here and then over here. So we can say, okay, x can be from 5 to infinity, or you can also just have an x value of -2, sorry. Right? So that's when f of x is greater than or equal to 0. G of x, well, g of x is actually just x plus 2, right? That's just a straight line with an intercept at -2, 0. So when is that going to be greater than or equal to 0? Well, x just has to be between -2 and infinity, right? That's just this part right here. Okay, and, right, in set notation, and, you can kind of think of that as intersection. So let's draw out these two sets here. So 5 and -2, 5 to infinity, or -2, and then also we have -2 to infinity. Now, where do these sets overlap each other, right? Where do they intersect? They intersect only at -2. X is equal to -2. Right? Let's think about this now. When is f of x less than or equal to 0? Well, it's less than or equal to 0 all the way from here, 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 and here, right? So negative infinity all the way to 5, including 5, because at 5 it's exactly 0, and we can have it be exactly 0. When is g of x less than equal to 0? G of x looks like this. So we get negative infinity to negative 2. Right? Let's see this. So we have 5 and we have negative 2. So negative infinity all the way to 5 looks like this. Negative infinity all the way to negative 2 looks like this. Where do these two overlap each other? Well, they overlap each other here. All there, right? So that's just negative infinity to negative 2. Right? And so remember, we can either have this case or we can have this case. The word or, you can think of it as union, right? So we have negative infinity to negative 2. This one is just a single value of just negative 2. So, we can have either one. If you combine those together, we just get negative infinity to negative 2. Right? So I hope that makes sense. Okay, this is a pretty big question, right? And we don't have too much longer to go here. So, okay. Consider f of x is 3 over 8 times 4 minus 3x, and x is between 0 and 4 over 3. The continuous random variable x has a probability density function of f of x, as we can see. Find k such that the probability x is greater than k. Right? X is greater than k is 9 over 16. What's the probability x is greater than k? Right? That's the integral from k to 4 over 3. Because 4 over 3 is the end of the probability density function. And then we can just put the function in the integral. Because 3 over 8 is just a constant number multiplying by the function, we can just take that out of the integral, makes our life a bit easier. And this is actually probability that x is greater than k, right? Okay, let's set up our bounds. What's the antiderivative of 4 minus 3x? That's 4x minus 3x squared over 2. And the bounds are from k to 4 over 3. Right, so let's put 4 over 3 into this thing here. So 4 times 4 over 3 is 16 over 3. Minus, okay, if we put 4 over 3 into this, let's see what happens. 3 times 4 over 3 squared over 2. That's just 16 over 9. 3 times 16 over 9 is 16 over 3. Divide that by 2. That's 16 over 6. That's just 8 over 3. And then minus, let's plug in k. So we get 4k minus 3k squared over 2. Get rid of this. We need the working space. Right? Okay. So now what can we do? All right. Now what can we do? Well, first of all, 16 over 3 minus 8 over 3 is just 8 over 3. Right? And then you have minus 4k plus 3k squared over 2. This is the probability. Oh, sorry. This is the probability that x is greater than k. This has to equal 9 over 16. Right? So what can we do? We can multiply both sides by 8 to get rid of this. If we do that, we'll get 9 over 2. And then we can multiply both sides by 1 over 3 to get rid of this. So we get 8 over 3 minus 4k plus 3k squared over 2 is equal to 3 over 2. Now I'm going to multiply both sides by 6 to get rid of every single fraction here. I don't like working with fractions, right? It's just easier to work with whole numbers. So if I multiply both sides by 6, I get this. So 9k squared minus 24k plus 16 is equal to 9. So 9k squared minus 24k, if we move the 9 to the other side, that just becomes a 7. Right, okay, this looks quite tricky to solve. Let's use the quadratic formula. So we get k is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So negative of negative 24 is just 24, plus or minus square root. Let's figure out what negative 24 squared is. Numbers are getting quite big. That's just negative 24 times negative 24. That's the same as 24 times 24. Let's figure that out. So that's 576. Right? And then we have minus 4 times 9 times 7. So 4 times 9 is actually 36. 36 times 7 is going to be 252. And all over 2 times 9, which is 18. So what's 576 minus 252? That's going to be 324. Now, 324, the square root of 324 should actually be 18. Right? Because let's check that out. What's 18 times 18? Yeah, so it's actually 324. So square root of 324, and I know the numbers are getting really big here, is actually 18. So let's bring this up here for a second. I know that we're kind of running out of space, so we get 24 plus or minus 18, all divided by 18. Right, so k can equal 24 minus 18 over 18, or k can equal 24 plus 18 over 18. Now, what's 24 minus 18? That's 6 over 18, right? Yep. And that can simplify to 1 over 3. Or k can be this. And 24 plus 18, arithmetic, right? That's going to be 42 over 18. Right? That's going to be 7 over 3. So we get k is equal to a third, or k is equal to 7 over 3. Now, obviously, k can't be outside of the probability density function, right? That would just make no sense. And a value of 7 over 3 is actually outside, because the maximum value it goes up to is 4 over 3. So therefore, k is actually equal to a third. Right? That's going to be our final answer. That's a huge question, right? A lot of working out. Okay, the function h of x is a transformation of f of x such that h of x is equal to m times f of x plus n, where m and n are real numbers. Find the integral from 0 to 4 over 3 of h of x dx in terms of m and n. Okay, so let's replace h of x with what they actually gave us. Now we can actually apply this to each term in this function individually. So integral from 0 to 4 over 3 m times f of x dx plus integral from 0 to 4 over 3 n dx. Now m is a constant number, right? So we can take that out of that integral. And then the integral or antiderivative of n dx, so with respect to x, is just nx. And also, what's the integral from 0 to 4 over 3 for f of x dx? Well, that covers the entire probability density function, right? That's the area under the entire probability density function. That's always going to be 1. So we just get m plus, now let's take this and substitute 4 over 3. So we get 4n over 3 minus, let's substitute 0, that's just 0. So we get m plus 4n over 3. So therefore, the integral from 0 to 4 over 3, h of x dx, is actually m plus 4n over 3. So that's in terms of m and n, right? There we go. Okay, it's been quite a tiring exam so far, right? A lot of crazy numbers coming up, but this is the last question, right? And not too much more to go. Consider the functions f of x is equal to w squared over x minus 1 squared, and g of x is equal to x minus w squared. If w is equal to negative 3, find the 4 solutions to f of x is equal to g of x. Okay, w is equal to negative 3. Let's find the equation of f of x. So that's going to be negative 3 squared over x minus 1 squared. That's 9 over x minus 1 squared. G of x would be x minus negative 3, and then squared. X minus negative 3, 2 negatives make a positive, so x plus 3 squared. Now, we want to let f of x equal g of x, right? So let's equate the two. So 9 over x minus 1 squared is equal to x plus 3 squared. And we can write x plus 3 squared as x plus 3 squared divided by 1. Now we have a fraction is equal to a fraction. We can cross multiply. So x minus 1 squared times x plus 3 squared is equal to 9. Let's take the 9 to the other side. And now we have to be really, really tricky, right? We have to apply difference of squares. So remember, a squared minus b squared is the same as a plus b times a minus b. So how would we apply that? Well, x minus 1 squared times x minus 3 squared is the same as x minus 1 times x plus 3. Square the whole thing, and then 9 is the same as just 3 squared. So if we apply that, we get a. In this case, a is actually x minus 1 times x plus 3, plus b, and b is 3, so plus 3, times a, which is the same thing, minus b, which is 3. So using null factor law, we get x minus 1 times x plus 3 is equal to 0, or x minus 1 times x plus 3 minus 3 is equal to 0. Right? Let's tackle the first one first. First, we need to find out what's actually x minus 1 times x plus 3. That's going to be x squared plus 3x minus x minus 3. That's going to be x squared plus 2x minus 3. So for the first thing, we have x squared plus 2x minus 3. Then we have a plus 3 is equal to 0. Negative 3 plus 3 is 0, so x squared plus 2x is equal to 0. Factor out an x. we get x is equal to 0 or x is equal to -2. That's 2 out of our 4 solutions. Now, this is a 3-mark question, so I'm guessing that the, not really guessing, I know, but I know that the other solutions are going to be a lot trickier to find than these ones, right? Otherwise, it wouldn't really be a 3-mark question. So let's do the second one. Remember, we already found this. That's just x squared plus 2x minus 3. Minus 3 is equal to 0. Minus 3 minus 3 is -6. Right? And here, you could try the old-fashioned method of 2 numbers that add up to 2, 2 numbers that multiply to -6. Right? But you won't actually be able to find these 2 numbers. It's going to be, it's not possible to really find these 2 numbers. So once again, we have to use the quadratic formula. So we get -b plus or minus the square root of b squared. So b is 2, 2 squared is 4. Right? Minus 4 times a, which is 1, times c, which is -6. All divided by 2 times a, which is 1. Now, we have 4 minus 4 times 1 times -6. What's 4 times -6? That's going to be -24. So you just get 4 plus 24, that's actually 28. So -2 plus or minus root 28 over 2. Now root 28, we can actually simplify that a little bit more, right? Root 28 is actually the same as 4 times 7. And then divide all that by 2, right? So square root of 4 is obviously 2. So we get this. And then we can divide everything by 2. We get -1 plus or minus root 7. So therefore, our 4 solutions is we have x is equal to -2, or x is equal to -1 minus root 7, or x is equal to 0, or x is equal to -1 plus root 7. Right? And that should be all of our solutions there. Okay, getting close to the end now. So find in terms of w. Oh, sorry. So consider the case where w is greater than 0. Okay? Find in terms of w the coordinates of the minimum point of the graph of this. This is just a parabola, right? Let's actually expand this. So we get x squared minus wx minus x plus w. Right? If we expanded that and we got this is just a parabola. The minimum point on a parabola is just its turning point. So let's just find the turning point. So let's do dy dx. It's going to be 2x minus w minus 1. We're going to let dy dx equal 0. So you get 2x minus w minus 1 is equal to 0. 2x is equal to w plus 1. And x is equal to w plus 1 over 2. That's our x coordinate of the minimum point. Let's put this back into the original function to find the y coordinate. So when x is equal to w plus 1 over 2, y is going to be w plus 1 over 2 minus 1 times w plus 1 over 2 minus w. Now, what's w plus 1 over 2 minus 1? That's w minus 1 over 2. And what's w plus 1 over 2 minus w? That's negative w plus 1 over 2. Now, you might notice, hold on, negative w plus 1 over 2, if I factor out a negative, that's just w minus 1 over 2. So what do we actually have here? We actually have negative of w minus 1 squared over 4, right? Because the negative stays out. W minus 1 times w minus 1 is w minus 1 squared, and then 2 times 2 is 4. So therefore, the point is actually going to be an x-coordinate of w plus 1 over 2, and a y-coordinate of negative w minus 1 squared over 4. Okay, hence or otherwise, find the positive values of w for which f of x is equal to g of x has exactly 3 solutions. Now that's kind of tricky, right? Let's find the rule of f of x again. It's going to be w squared over x minus 1. X minus 1 squared, actually, sorry. And g of x is going to be x minus w squared. Let's equate these together because we want to find, the solutions to this equation here, right? So we get w squared over x minus 1 squared is equal to x minus w squared. And you can write that like this. Let's try to cross multiply. So we get x minus w squared times x minus 1 squared is equal to w squared. Okay, now I want you to think about this really carefully. This is the key point to this question. What would the graph of this look like? Well, this is squared. Well, first of all, there'd be an intercept at w and an intercept at 1, right? And there's a squared on both of these terms. So it would kind of look like this. And we're looking for when this graph is the same as the graph of just w squared, right? Right? When it's the same as the graph of w squared. Now you'll see normally, if you just draw this, there's 2 solutions to this equation. Generally, there's 2 solutions to this equation. We want 3. What's the only way that we can have 3 solutions? The only way we can have 3 solutions is if it actually looks like this, right? Where this local maximum point, right? This local maximum point is the same height as w squared. That's when we have 3 solutions, okay? So first of all, let's find this right here, right? Let's find that local maximum of the graph. So let's take a derivative. So product rule, that's going to be first function times the derivative of the second function plus the second function times the derivative of the first function. So we can clean this up a little bit. We get 2 times x minus 1, x minus w squared, plus 2 times x minus 1 squared, x minus w, right? You'll see here, if you look carefully, we can actually factor out 2 times x minus 1, x minus w. So we get left with x minus w plus x minus 1. That's just gonna be 2 times x minus 1 times x minus w times 2x minus w minus 1. Now, if I want to find the local maximum of the graph, I have to let the derivative equal 0. So we're going to let dy dx equals 0. Oh, so I shouldn't write dy dx because there is no y that's actually defined, right? I should say we're going to let 2 times x minus 1, x minus w, 2x minus w minus 1 equals 0. Right, so I'm just going to kind of go down here. Now, null factor law tells us x is equal to 1, or x is equal to w. These are things that we already expect, because we know there's stationary points at x is equal to w and x is equal to 1. However, there's also one more stationary point. That has to be this one. Right? So, or 2x minus w minus 1 is equal to 0. So if you solve that, x is equal to w plus 1 over 2. Right? X is equal to w plus 1 over 2. That's the x coordinate of the local maximum. We also need to find the y coordinate. Right? So what do? We take this value, put it back in here. Now, if you notice something, there's something very strange, right? X minus w times x minus w squared times x minus 1 squared, right? That's actually just the same as x minus w times x minus 1, and then square the whole thing. And we want to replace x with w plus 1 over 2, right? So that would look like w plus 1 over 2 minus w times w plus 1 over 2 minus 1, and then square the whole thing. Didn't we already find this value in the previous part of the question, right? Right? We already actually found this right here. That was actually equal to negative w minus 1 squared over 4. And then you're going to square the whole thing. That's actually going to give us w minus 1 to the 4 over 16. Yep. This is the y value of the local maximum. Right? So that's the y value of the local maximum. When do we get exactly 3 solutions? When the y value of the local maximum is exactly the same as w squared. So what we need to do is we need to actually solve this right here. So we get w minus 1 to the 4 is equal to 16w squared. Let's take that to the other side. If you haven't noticed already, it's another difference of squares, right? W minus 1 to the 4 is the same as w minus 1 squared, square it again, minus 4w squared. So that's going to be a plus b, so w minus 1 squared plus 4w times a minus b, so w minus 1 squared minus 4w is equal to 0. Right, so let's see. We can get w minus 1 squared plus 4w is equal to 0. W minus 1 squared is just w squared minus 2w plus 1 plus 4w is equal to 0. This is w squared plus 2w plus 1 is equal to 0. We can do w squared plus w plus 1 is equal to 0. So we get, if we factor out a w, or better yet, instead of doing all of this, you can actually just recognize that w squared plus 2w plus 1 is actually just w plus 1 squared. And so we get w is equal to negative 1. However, we are going to reject that because we only need to find the positive values of w. So reject w is equal to negative 1, as w is actually positive. It's greater than 0. We still have the other part to do. So let's see. Right, we get w minus 1 squared minus 4w is equal to 0. W minus 1 squared is w squared minus 2w plus 1. And then we have minus 4w is equal to 0. W squared minus 6w plus 1 is equal to 0. Let's try to use quadratic formula again. So negative b, that's just going to be 6, plus or minus square root of b squared, minus 4 times a, which is 1, times c, which is 1. All divided by 2 times a, which is 2 times 1. Now, what's negative 6 squared? That's 36. And then 36 minus 4 is actually 32. Now, we can simplify this a bit more. Root 32 we can write as root 8 times 4. That's going to be, we can take out that there. Oh, we can actually simplify this even a bit more, actually. All right, we can write this as actually 16 times 2, right? That's also 32. So we get 6 plus or minus 4 root 2 over 2. You can divide everything through by 2. We get 3 plus or minus root 2. Right, so therefore, the positive values of W that make those have exactly 3 solutions is 3 minus root 2, or W is equal to 3 plus root 2. That's going to be our final answer, right? That is the end of the 2025 exam 1. Absolutely some hectic questions in here, right? Some really crazy working out. But I hope this exam went well for you all. And I hope you get the study score that you guys want. And nothing but the best of luck for tomorrow's exam too. Thank you so much for watching.